service endpoints. All right, yeah. Improve security for your Azure resources. VNet endpoint, VNet private address spaces can be overlapping and so cannot be used to uniquely identify traffic originating from your VNet service endpoint. Secure Azure resources to your virtual network. Secure Azure service resources to your virtual network by extending VNet identity to the service. When the service endpoint are enabled in your virtual network, you secure Azure service resources to your virtual network by adding a virtual network rule. The rule improves security by fully removing the public internet access to resources. By The rule improves security by fully removing public internet access to resources and allowing traffic only from your virtual network. And allowing traffic only from your virtual network. And allowing traffic only from your virtual network. Optimal routing for Azure service traffic from your virtual network. Any route any route in your virtual network that force internet traffic to your today any route in your virtual network that force internet traffic to your premises and or virtual appliances known as forced tunneling also force Azure service traffic to take the same route as the internet traffic. Service endpoint provide optimal routing for Azure traffic. Endpoint always takes service traffic directly from your virtual network to the service on the Microsoft Azure backbone network. Keeping traffic on the Azure backbone network allows you to continue auditing and monitoring outbound internet traffic from your virtual networks through forced tunneling without impacting service traffic. Learn more about user-defined routes and forced tunneling. Simple to set up with less management overhead. You no longer need reserved public IP address in your virtual network to secure Azure resources through IP firewall. There are no NAT or gateway devices required to set up the service endpoint. Service endpoints are configured through the subnet. There is no additional overhead to maintaining the endpoints. There is no additional overhead to maintaining the endpoints. With service endpoints, the virtual machine IP address switches from public to private IPv4 addresses. Okay, virtual machine IP addresses switches from public to private IPv4. Existing Azure Service Firewall rules using Azure public IP address will stop working with this switch. Ensure Azure Service Firewall rules allow for this switch before setting up service endpoints. You may also experience temporary interruption to service traffic from this subnet while configuring service endpoints. Hmm. Determine service endpoint service. It is easy to add a service endpoint to virtual network. Several services are available, including Azure Active Directory, Cosmos DB, Event Hub, Key Vault, Service Bus, SQL, and storage. Azure Storage generally available in all regions. This endpoint gives traffic an optimal route to Azure Storage service. Each storage account supports up to 100 virtual network rules. Azure SQL Database Azure generally available in all Azure, a firewall security feature that controls whether the database server for your single databases and that secure. A firewall security feature that controls whether the database server for your single databases and Elastic Pool in Azure SQL database, or for your databases and SQL data accept communications that are sent from particular subnets in virtual network. Azure database for Postgre and server, SQL Server and MySQL, generally available in Azure regions where database service and is available. Generally available in Azure regions where database service is available. Generally available in Azure regions where database service is available, virtual network service endpoints and rule extend the private address space of virtual network to your Azure database for PostgreSQL and MySQL server. Azure Cosmos DB generally available in all Azure regions. You can configure Azure Cosmos DB account to allow access from a specific subnet of virtual network. You can configure Azure Cosmos to allow access from specific subnet of virtual network by enabling service endpoint to access Azure Cosmos DB on the subnet within a virtual network. The traffic from that subnet is sent to Azure Cosmos DB with the identity of the subnet and virtual network. Traffic from the subnet is sent to Azure Cosmos DB with the identity of the subnet and virtual network. Once the Azure Cosmos DB service endpoint is enabled, you can limit the access to subnet by adding it to your Azure Cosmos DB account. You can limit the access to the subnet by adding it to your Cosmos DB Azure Cosmos account. Azure Key Vault. Azure Key Vault generally available in all Azure regions. The virtual network service endpoint for Azure Key Vault allows you to restrict access to a specified virtual network. Generally available in all Azure regions, the virtual network service endpoint for Azure Key Vault allow you to generally available in all Azure regions. The virtual network service endpoints for Azure Key Vault allow you to restrict access to specified virtual network. The endpoint also allow you to restrict access to list of IPv4 address ranges. Any user connecting to Key Vault from outside those sources is denied access. Azure Service Work Bus and Azure Event Hub generally available in all Azure regions. The integration of Service Bus with Virtual Network Service Endpoint enables secure access to messaging capabilities from workloads like generally available in all Azure regions. The integration of Service Bus with Virtual Network and Service Endpoint enables secure access to messaging capabilities from workload like virtual machines that are bound to virtual networks with the network traffic being secured on both ends. Note, adding service endpoints can take up to 15 minutes to complete. Each service endpoint integration has its own Azure documentation page. Private link uses compute private endpoint, Azure private link, only access mapped resources. Azure Private Link provides private connectivity from virtual network to Azure platform as a service, customer owned or Microsoft partner services. It simplifies network architecture and secures the connection between endpoint in Azure by eliminating data exposure to public internet. Private connectivity to services on Azure. Traffic remains on the Microsoft network with no public internet access. Connect privately to services running in other Azure regions. Private link is global and has no regional restrictions. Integration with on-premises and peer networks. Access private endpoints over private peering or VPN tunnels from on-premises or peered virtual networks. Microsoft hosts the traffic, so you don't need to set up public peering or use the internet to migrate your workloads to the cloud. Access private endpoints over private peering or VPN tunnels. Integration with on-premises and peered network. Access private endpoints over private peering or VPN tunnels from on-premises or peered virtual network. Microsoft hosts the traffic, so you don't need to set up public peering workloads to cloud. Integration with on protection against data exfiltration for Azure. It will use private link to map private endpoints to Azure Platform as a Service resources. When there is security incident in your network, only the mapped resource would be accessible, eliminating the threat of data exfiltration. Services delivered directly to your customer's virtual network. Privately consumed Azure Platform as a Service, Microsoft partner, and your own services in your virtual networks on Azure and your own service. Privately consume Azure Platform as a Service, Microsoft partner, and your own services in virtual networks on Azure. Private link works across Azure Active Directory tenants to help unify your experience across services. Send, approve, or reject requests directly without permissions or role based access control. How do you use private link to bring services delivered on Azure into your private virtual network by mapping it to private endpoint or privately deliver your services in your customers' virtual networks. All traffic to the service can be routed through the private endpoint, so no gateways. All traffic to the service can be routed through the private endpoint, so no gateways, NAT devices, express route or VPN connections, or public IP addresses are needed. Public IP addresses are needed. Private link keeps traffic on the Microsoft global network. Knowledge check. Let's check the knowledge, guys. Which of the following statement best describes Azure routing? The administrator can override existing system routes? No. Azure gateways are needed to route traffic between subnets? No. When when the next hop type is none, traffic is dropped. That's correct. When creating user-defined routes, which of the following is valid next hop types? Internet load balancer, express route. User-defined routes. Which of the following is valid next hop types? Next hop. User-defined routes. I think internet is the correct answer. Okay, a company needs to extend their private address space in Azure by providing a direct connection to Azure resources. Which of the following should be implemented? Extend their private address space in Azure by providing a direct connection. Virtual network endpoint. A company need to extend their private address space in Azure by providing a direct connection to Azure resources. Okay, everything is correct. Network routes, the network route control the flow of traffic through your network, so you can customize these routes. Implement service endpoints. Network route control the flow of traffic through your network, so you can customize these routes. Implement service endpoints and private links. Hmm. Okay, where are we now? Configure Azure Load Balancer. You'll learn how to configure an internal or public load balancer. Okay, let's do this, boy. Let's do this, boy. Let's do this. Oh, hi. Are you okay? Oh, really? Thank you. I mean, I'm not afraid of Corona. Coronavirus. Dmitry Maxim of Galhat. Lol. Okay. Many apps need to be resilient to failure and scale easily when demand increases. You can address those needs by using Azure Load Balancer. You can address those needs by using Azure Load Balancer. Suppose you work for a healthcare organization that's launching a new portal application in which patients can schedule and appointments. Suppose you work for a healthcare organization that's launching a new portal application in which patients can schedule appointments. The application has patient portal and a web application front end and a business tier database. Patient portal and web application. The database is used to by the front end to retrieve and save patient's information. The new portal needs to be available around the clock to handle failures. Portal must adjust to fluctuations in load by adding or removing resources to match the load. Organization needs a solution that distributes work to virtual machines across the system as virtual machines are added. Organization needs a solution that distributes work to virtual machines across the system. So that distributes work to virtual machines across the system as virtual machines are added. The solution should detect failures and reroute jobs to virtual machines as needed. Reroute jobs to virtual machines as needed. Improve resiliency and scalability helps ensure that patients can schedule appointments from any location. Resiliency and scalability helps ensure patients can schedule appointments from any location. You must distribute incoming network traffic across a group of backend resources or services such as virtual machines. You must scale your applications while maintaining throughput and keeping response times low. The Azure Load Balancer delivers high availability and network performance to your applications. The load balancer distributes net inbound traffic to backend resources using load balancing rules and health probes. Azure Load Balancer delivers high availability and network performance to your applications. The load balancer distributes inbound traffic to backend resources using load balancing rules and health probes. Load balancing rules determine how traffic is distributed to the backend. Load balancing rules determine how traffic is distributed to the backend. Health probes ensure the resources in the backend are healthy. And health probes. Front end backend pool. The load balancer can be used for inbound and outbound scenarios and scales up to millions of TCP and UDP application flows. Load balancer can be used for inbound and outbound scenarios and scales up to millions of TCP and UDP application flows. Keep this diagram in mind since it covers the four components that must be configured for your load balancer. Keep this diagram in mind since it covers the four components that must be configured for your load balancer. Front-end IP configuration, back-end pools, front-end IP configuration. Keep this diagram in mind as since it covers the four components that must be configured in for your load balancer. Four front-end IP configuration, back-end pools, health probes, and load balancing rules. implement a public load balancer. There are two types of load balancer, public and internal. A public load balancer maps the public IP address and port number of incoming traffic to the private IP address and port number of the VM. Mapping is also provided for the response traffic from Mapping is also provided for the response traffic from the VM. By applying load balancing rules, you can distribute specific types of traffic across multiple VMs or services. For example, you can spread the load of incoming web request traffic across multiple web servers. The diagram shows internet client sending web page request to the public IP address of web app on the TCP port 80. Azure Load Balancer distributes the request across the three VMs in the load balanced set. Public load balancer, web tier subnet. Implement an internal load balancer. An internal load balancer directs traffic to resources that are inside a virtual network or that use a VPN to access Azure infrastructure. An internal load balancer directs traffic to resources that are inside a virtual network or that use a VPN to access Azure infrastructure. Front-end IP addresses. An internal load balancer directs traffic to the resources that are inside a virtual network or that use a VPN to access Azure. Okay, implement internal. An internal load balancer directs traffic to resources that are inside the virtual network or that use a VPN to access Azure infrastructure. Front-end IP and virtual networks are never directly exposed to an internet endpoint. Internal line of business application run in Azure and are accessed from within Azure or from an on-premises resources. For example, an internal load balancer could receive database requests that need to be distributed to backend SQL servers. For example, an internal load balancer could receive database requests that need to be distributed to backend SQL servers. VM inter For example, internal load balancer could receive database requests that need to be distributed to backend SQL server. An internal load balancer enables the following type of load balancing. Within a virtual network, load balancing from VMs in the virtual network to a set of VMs that reside within the same virtual network. An internal load balancer enables the following type of within a virtual network load balancing from VMs in the virtual network to a set of VMs that reside within the same virtual network. For a cross-premises virtual network, load balancing from on-premises computer to a set of VMs that reside within the same virtual network. And multi-tier application load balancing for internet-facing multi-tier application where the backend tiers are not internet-facing. The backend tiers require traffic load balancing from the internet-facing tier. For line of business load balancing for line of business applications that are hosted in Azure without additional load balancer hardware or software. This scenario includes on-premises servers that are in the set of computers whose traffic is load balanced. A public load balancer could be placed in front of internal load balancer to create a multi-tier can be placed in front of internal load balancer to create a multi-tier application. Determine load balancer SKU. When you create Azure load balancer, you select the type internal or public of load balancer. You can select SKU. The load balancer support both basic and standard SKU, each differing in scenario, scale, features, and pricing. The standard load balancer is a newer load balancer product with an expanded and more granular feature set over basic load balancer. It is superset of the basic load balancer. Features: backend pool basic up to 300, standard up to 1000. Health probes basic HTTP TP, standard HTTPS TP TCP. Availability zones not available. Zone redundant zonal front end or inbound and outbound traffic. Multiple front ends inbound only, inbound and outbound. Secured by default, open by default, NSG optional. Closed to inbound flows unless allowed by NSG. Internal traffic from the virtual networks to the internal load balancer is allowed. SLA not available 99.99%. The basic SKU can be upgraded to standard SKU, but new designs and architecture should use the standard load balancer. Create backend pools. To distribute traffic, a backend address pool contains the IP address of the virtual NICs that are connected to load balancer. How you configure the backend pool depends on whether you are using the standard or basic SKU. Backend pooled endpoints. Standard SKU, any virtual machine in a single virtual network. This includes blend of virtual machine availability sets and virtual machine scale sets. Basic SKU, virtual machines in a single availability set or a virtual machine scale set. Basic SKU, virtual machines in a single availability set or virtual machine scale set. Virtual machine in a single availability set or virtual machine scale set. Backend pools are configured from the backend pool blade. For the standard SKU, you can connect to an availability set, single virtual machine or a virtual machine. Backend pools are configured from the backend pool blade. For the standard SKU, you can connect to an availability set, single virtual machine or virtual machine scale set. Availability set, single virtual machine or virtual machine scale set. Availability set, single virtual machine or in the standard SKU you can have up to 1000 instances in the backend pool. Basically you can have up to 300 instances. Create load balancer rules. A load balancer rule defines how traffic is distributed to the backend pool. The rule maps are given front-end IP and port combination to a set of backend IP address and port combination. Before configuring the rule, create the front-end, backend, and health probe. The diagram shows a rule that routes front-end TCP connections to a set of backend web port 80 servers. The rule uses health probe that checks on HTTP port 80. Load balancing rules can be used in combination with NAT rules. For example, you could use NAT from the load balancer's public address to the you can use NAT from load balancer's public address to TCP 3389 on specific virtual machine. This allows remote desktop access from outside of Azure. Load balancing rules can be used in combination with NAT rules. For example, you could use NAT from load balancer's public address to TCP 3389 on a specific virtual machine. Load balancer public address to TCP 3389 on a specific. This allows remote desktop access from outside of Azure. Configure session persistence. By default, Azure Load Balancer distributes network traffic equally among multiple VM. By default, Azure Load Balancer distributes network traffic equally among multiple VM instances. By default, Azure Load Balancer distributes network traffic equally among multiple VM instances. The load balancer uses a five tuple. By default, Azure Load Balancer distributes network traffic equally among multiple VM instances. The load balancer uses a five tuple source IP, source port, destination IP, destination port, and protocol type hash to map traffic to available server. hash to map traffic to available server. It provides stickiness only within a transport session. Connection 1, connection 2, connection 3, internet load balancer, cloud services or virtual machine 1, virtual machine 2, virtual machine 3, DIP1, DIP2. By default, load balancer distribute network traffic equally among multiple VM instances. The load balancer uses 5 tuple source IP, source port, destination IP, destination, and protocol type. 5 tuple hash to map traffic to available servers. It provides stickiness only within a transport session. 5 tuple hash. Source IP, source port, destination IP, destination port, protocol. Session persistence specifies how traffic from a client should be handled. Session persistence specifies how traffic from a client should be handled. Session persistence specifies how traffic from a client should be handled. The default behavior is that successive request from session persistence specify how traffic from client should be handled. The default behavior is that successive request from client may be handled by any virtual machine. You can change this behavior. You can change this behavior. None default specifies any virtual machine can handle the request. Specifies any virtual machine can handle the request. Client IP specifies any virtual machine. Client IP specifies successive request to the same client IP address will be handled by same virtual machine. Client IP and protocol specifies successive request from the same IP and protocol combination will be handled by the same. Keeping session persistent information is important in applications that use a shopping cart. Can you think of any other applications? Hmm. Create help probe. A health probe allows the load balancer to monitor the status of your app. A health probe allows the load balancer to monitor status of your app. The health probe dynamically adds or removes VMs from the load balancer rotation based on their response to health checks. The health probe dynamically adds or removes VMs from the load balancer rotation based on their response to health checks. When a probe fails to respond, the load balancer stops sending new connections to the unhealthy instances. When a probe fails to respond, the load balancer stops sending new connections to the unhealthy instances. A health probe allows the load balancer to monitor the status of your app. Health probe dynamically adds or removes VMs from the load balancer rotation based on their response to health checks. Health probe dynamically adds or removes VMs from the load balancer rotation based on the response or to health checks. When a probe fails to respond, the load balancer stops sending new connection to unhealthy instances. There are two main types ways to configure health probes: HTTP and TCP. HTTP and TCP. A health probe allows load balancer to monitor the status of your health probe dynamically adds or removes VMs from the load balancer rotation based on their response to health checks. When a probe fails to respond, the load balancer stops sending new connections to the unhealthy instances. There are two main ways to configure health probe: HTTP TCP. HTTP custom probe: the load balancer regularly probes your endpoint every 15 seconds by default. The instance is healthy if it responds with HTTP 200 within the timeout period default of 31 seconds. The instance is healthy if it responds with an HTTP 200 within the timeout period or default of 31 seconds. Any status other than HTTP 200 causes the probe to fail. You can specify the port, the URI for requesting the health status from the backend, amount of time between probe attempts, and the number of failures that must occur for the instance to be considered unhealthy. The custom TCP custom probe, the probe relies on establishing successful TCP session to a defined probe port. If the specified listener on the VM exists, the probe succeeds. If connection is refused, the probe fails. You can specify port interval and the threshold. There is also a guest agent probe. This probe uses guest agent inside VM. It is not recommended when HTTP or TCP custom probe configurations are possible. Knowledge check. Let's do the knowledge check. A company provides customer a virtual network in the cloud. There are dozens of Linux virtual machines in another virtual network. Which Azure load balancer should be used to direct traffic between the virtual networks? Internal load balancer provides customer a virtual network in the cloud. And there are dozens in another virtual network. Which load balancer should be used to direct traffic between virtual networks? Internal load balancer. What is the default distribution type for the traffic through a load balancer? Default distribution type for traffic through a load balancer 5 tuple hash. And which configuration is required for internal load balancer? Virtual machines should be in the same virtual network. Virtual machines must be publicly accessible. Virtual machine must be in an availability. Must be in the same virtual network, I think. Yeah, that's correct. Continue. Okay, many apps need to be resilient to failure and scale easily when demand increases. You can address those needs by using Azure Load Balancer. You should now be able to identify features and usage cases for Azure Load Balancer, implement public and internal Azure Load Balancer, configure Load Balancer SKU, backend pool, session persistent, and health probes. Configure Load Balancer SKUs. Configure load balancer SKU, backend pool, session persistent, and health probes. Application gateway. Configure Azure Application Gateway. Okay, let's check this out. Configure Azure Application Gateway. You will learn how to configure Azure Application Gateway. Okay, Application Gateway. Imagine Imagine you work for the motor vehicle department of a government organization. Imagine you work for the motor vehicle department of governmental organization. The department runs several public websites. Imagine you work for motor vehicle department of government organization. Department runs several public websites that enable driver to register their vehicle and renew their driver license online. The vehicle registration website has been running on a single server and has suffered multiple outages because of server failures. This has resulted in frustrated drivers trying to register their vehicle by month's end before their registration expire. You would like to improve resiliency by adding multiple web servers to its site and distribute the load across them. You would also like to centralize their site on a single load balancing service. This will amply simplify the URLs for site visitor. Configure Azure Application Gateway. Application Gateway manages the request that client applications send to a web app. The application gateway uses application layer routing. Application layer routing routes traffic to a pool of web server based on the URL of a request. The backend pool can include Azure virtual machines, Azure virtual machine scale sets, Azure app service, or even an on-premises servers. So the application gateway uses round robin to send load balance request to the servers in each backend pool. Browser application gateway, HTTP, HTTPS listener, rule HTTP setting, and then pool. As application gateway uses round robin to send load balance request to the servers in each backend pool. The application gateway provides session stickiness. Use session stickiness to ensure client requests are in the same session are routed to the same backend server. Load balancing works in the OSI layer 7. Load balancer requests use the routing parameter host names and paths in the application gateway rules. In comparison, the Azure load balancer functions at the OSI layer 4 level. This means the Azure load balancer distributes traffic based on IP address of the target of a request. Additional features support for the HTTP, HTTPS, HTTP2, and WebSocket protocol, and a web application firewall to protect against web application vulnerabilities, end to end request encryption, auto scaling to dynamically adjust capacity as your web traffic load change, determine application gateway routing. Clients send requests to your web apps to the IP address or DNS name of the gateway. Clients send requests to your web apps to the IP address or DNS name of the gateway. Clients send requests to your web apps to the IP address or DNS name of the gateway. Clients send requests to your web apps to the IP address or DNS name of the gateway. Gateway routes requests to a selected web server in the backend pool using a set of rules configured for the gateway to determine where the request should go. There are two primary methods of routing traffic: path-based routing and multiple site routing. Path-based routing. Path-based routing sends requests with different URL paths, different pools of backend server. For example, you could send direct request with the path video to backend pool containing servers that are optimized to handle video streaming, and direct images request to a pool of servers that handle image retrieval. Multiple site routing. Multiple site routing configures more than one web application on the same. Okay, multiple site routing configures more than one web application on the same application. Multiple site routing configures more than one web application on the same application gateway instance. Multiple site routing configures more than one web application on the same application gateway instance. Okay. Multiple site routing configures more than one. Multiple site routing configures more than one web application on the multiple site routing configures more than one web application. Where are we? Multiple site routing configures more than one web application on the same application gateway instance. In a multi-site configuration, you register multiple DNS names, CNAMEs, for the IP address of application gateway, specifying the name of each site. The application gateway uses separate listeners to wait for requests for each site. Each listener passes the request to a different rule, which can route the request to servers in a different backend pool. For example, you could redirect all the requests for contoso.com to servers in one backend pool and request for Fabricam to another backend pool. The following diagram shows the configuration. Multi-site configurations are useful for supporting multi-tenant. Multi-site configurations are useful for supporting multi-tenant applications where each tenant has its own set of virtual machine. Multi-site configuration are useful for supporting multi-tenant applications where each tenant has its own set of virtual machines. Its own set of virtual or other resources hosting a web application. Other feature redirection. Redirection can be used to another site from HTTP to HTTPS. Rewrite HTTP header. HTTP headers allow the client and server to pass parameter information with the request or the response. Custom error pages. Application gateway allows you to create custom error pages instead of displaying the default error pages. You can use your own branding and layout using a custom error page. Redirection can be used to another site from HTTP to HTTPS. Rewrite HTTP header. HTTP headers allow the client and server to pass parameter information with the request or the response. Custom error pages. Application gateway allows you to create custom error pages instead of displaying default error pages. You can use your own branding and layout using custom error page. Application gateway component setup. Bro. Application gateway components. That application gateway has series of components that combine to route requests to a pool of web servers and to check the health of these web servers. Front end listener certificate port rule stitches front end to back end traffic. Back end pool settings for back end traffic port stickiness rogue timeout. Front end IP address Front-end IP client requests are received through a front-end IP address. You can configure application gateway to have a public IP address, a private IP address, or both. Application gateway can't have more than one public and one private IP address. Listeners. Application gateway uses one or more listeners to receive incoming requests. Application gateway uses one or more listeners to receive incoming requests. A listener accepts traffic arriving on a specified combination of protocol, port, host, and IP address. Listener accepts traffic arriving on a specified combination of port, protocol, host, and IP address. Each listener routes request to backend pool of servers with following routing rules that you specify. A listener can be basic or multi-site. A basic listener only routes requests based on the path in the URL. A multi-site listener can also route requests using the host name element of the URL. Listener also handles TLS SSL traffic for securing your application between the user and application gateway. Listeners also handle TLS SSL certificates. Listeners also handle TLS SSL certificates for securing your application. Listeners also handle TLS SSL certificates for securing your application between the user and application gateway. Listeners also handle TLS SSL certificates for securing your application between the user and application gateway. Listener also handles TLS SSL certificates for securing your application between the user and application gateway. Routing rules. A routing rule binds a listener to the backend pools. A rule specifies how to interpret the hostname and path element in the URL of a request. A routing rule binds a listener to the backend pools. A routing rule binds the listener to the backend pools. A rule specifies A routing rule binds a listener to the backend pools. A rule specifies how to interpret the hostname and path element in the URL of request and then direct the request to appropriate backend pool. A routing rule also has an associated set of HTTP settings. These HTTP settings indicate whether these HTTP settings indicate whether and how traffic is encrypted between application gateway and the backend servers. Other configuration information include protocol, session stickiness, connection draining, request timeout period, and health proofs. Backend pools. Backend pool. A backend pool references the collection of web servers. You provide the IP address of each web server and the port on which it listens. A backend pool references the collection of web servers. You provide the IP address of each web server and the port on which it listens for the request when configuring the pool. A backend pool references a collection of web servers. A backend pool references a collection of web servers. You provide the IP address of each web server and the port on which it listens for request when configuring the pool. Each pool can specify a fixed set of virtual machines, a virtual machine scale set, and an app hosted by Azure App Services, or a collection of on-premises servers. Each backend pool has an associated load balancer. Each backend pool has an associated load balancer that distributes work across the pool. Web Application Firewall. Web Application Firewall WAF is an optional component that handles incoming requests before they reach a listener. The Web Application Firewall checks each request for many common threats based on the Open Web Application Security Project (OWASP). Common threats include SQL injection, cross-site scripting, command injection, HTTP request smuggling, HTTP response spitting, a remote file inclusion, bots, crawlers, scanners, and HTTP protocol violation and anomalies. OWASP has defined a set of generic rules for detecting attacks. They defined a set of generic rules for detecting attacks. These rules are referred to as the core rule set (CRS). The rule set are under continuous review as attacks evolve in sophistication. WAF support two rule sets, CRS 2.2.9 and CRS 3.0. CRS 3.0 is the default and more recent of these rule sets. If necessary, you can opt to select only specific rules in a rule set targeting certain threads. Additionally, you can customize the firewall to specify which elements in request to examine and limit the size of messages to prevent massive uploads from overwhelming your server. WAF is enabled on your application gateway by selecting the WAF tier when you create a gateway. WAF is enabled on your application gateway by selecting the WAF tier when you create a gateway. WAF is enabled on your application gateway by selecting the WAF tier when you create a gateway. Health probes. Health probe determine which servers are available for load balancing in the backend pool. The application gateway uses a health probe to send a request to the server. When the server returns an HTTP response with a status code between 200 and 399, the server is considered healthy. When the server returns an HTTP response with the status code between 200 and 399, the server is considered healthy. When the server returns an HTTP response with the status code between 200 and 399, server is considered healthy. If you don't configure health probe, application gateway creates default probe that waits for 30 seconds before deciding the server is unavailable. Okay, knowledge check. Which criteria does application gateway use to route traffic request to a web server? Hostname, port, and path in the URL, the region in which the server hosting, the user authenticate, hostname, port, and path. Which load balancing strategy does the application gateway implement? Distribute request to each available server in backend pool, round robin. Distributes request to the server in backend pool with the lightest load. Polls each server in the backend pool in turn and sends the request to the first server that responds. Application gateway implement. Which load balancing strategy? Round robin distributes the server in the backend pool with lightest load. Hmm, I don't know. The web team is installing an application gateway. They want to ensure incoming requests are checked for common security threats like cross-site scripting and crawlers. To address these concerns, what should be done? Web application WAF. Which load balancing strategy does the application gateway implement? Distribute requests to each available server in the backend pool in turn, round robin. So distribute requests to the server in backend pool with the lightest load. Distribute all each server in the backend pool in turn and then send. I think this sounds correct because there's health check and that's why. That's incorrect. Application gateway does not use polling. Then it should be round robin. That's correct. Okay. Continue. The application gateway provides load balancing and application routing capabilities across multiple websites. Application gateway provides load balancing and application routing capabilities across multiple websites. Several routing methods are available, including path-based routing, also application gateway, web application firewall with built-in security features. Cool. Good. Okay, we will quickly go through this design and IP addressing schema. We'll quickly go through this. A good Azure IP addressing schema provides flexibility, room for growth, and integration on-premises network. The schema ensures that communication works for deployed resources, minimizes the public exposure of system, and gives organization flexibility in its network. If not properly designed, system might not be able to communicate, and additional work will be required to remediate. And additional work will be required to remediate. Yeah. Yep. 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 Dun, 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 dun. Distribute your services across Azure Virtual Network and integrate them by using virtual network peering. Let's do this. Why waste time? Let's do this. Imagine you are the solution architect. Imagine, okay, I'll imagine that. For an engineering company that has been migrating services into Azure, the company has deployed services into separate virtual network. It has configured privately several virtual network. It has configured private connectivity between virtual networks. It hasn't configured private connectivity between virtual networks. Several business units have identified services in these virtual networks that need to communicate with each other. You need to enable this connectivity, but you don't want to expose these services to internet. You also want to keep the integration as simple as possible. In this module, you will learn about virtual network connection options and why virtual network peering is suited to this scenario. You will create three virtual networks and configure virtual network peering between them. You will then test your configuration to make sure it meets your connectivity goals. Sure, why not? Let's do that. Let's do that. Let's do that. Let's do that. Yeah, let's do that. 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 Of course, why not? Let's do that. Ta-da! Connect services by using virtual network peering. Let's do that. Let's do that. Okay. Connect services to virtual network. Connect services by using virtual network peering. You can use virtual network peering to directly connect Azure virtual networks. When you use peering to connect virtual networks, virtual machines in these networks can communicate with each other as if they were in the same network. Hmm. Virtual machines in these networks can communicate with each other as if they were in same virtual network. These networks can communicate with each other as if they were in same virtual. In paired virtual networks, traffic between virtual machines is routed through the Azure network. The traffic uses only private IP addresses. It doesn't rely on internet connectivity, gateways, or encrypted connections. Hmm. Gateways or encrypted connections. The traffic is always private and it takes advantage of the high bandwidth and low latency of Azure backbone network. VNet 1, VNet 2 peering connection. Hmm. The two types of peering connections are created in the same way. Virtual network peering connects virtual networks in the same Azure region, such as two virtual networks in North Europe. And global virtual network peering connects virtual networks that are in different Azure regions, such as virtual networks in North Europe and a virtual network in West Europe. Interesting. Mm, all right. Virtual network peering doesn't affect or disrupt any resources that you have already deployed to the virtual networks, but when you use virtual network peering, consider the key features that the following section define. Reciprocal connections. When you create a virtual network peering connection in only one virtual network to connect to a peer in another virtual network, you are not connecting the networks together. To connect the networks by using virtual network peering, you have to create connections in each virtual network. In only one virtual network to connect to a peer in another network, you are not connecting the networks together. To connect the networks by using virtual network peering, you have to create connections in each virtual network. Think of how you connect two network switches together. You connect a cable to each switch and maybe configure some settings so that the switches can communicate. Virtual network peering requires similar connections in each network. Reciprocal connections provide this functionality. Cross subscription virtual network peering. You can use virtual network peering when both virtual networks are in different subscriptions. This might be necessary for mergers and acquisitions or to connect virtual networks in subscriptions that different departments manage. Networks in subscriptions or to connect virtual networks in subscriptions that different departments manage. Virtual networks can be in different subscriptions and the subscriptions can use the same or different Azure Active Directory tenants. Okay. Can be in different subscription and the subscription can use same or different Azure Active Directory tenants. When you use virtual network peering across subscriptions, you might find that an administrator of one subscription doesn't administer the peer network subscription. The administrator might not be able to configure both ends of the connection to pair the virtual network when both subscriptions are in different Azure Active Directory tenants. The administrator of each subscription must grant peer subscriptions administrator the network contributor role on the virtual network. Transitive virtual network peering is non-transitive. Only virtual networks that are directly peered can communicate with each other. The virtual networks cannot communicate with peers of their peers. Suppose, for example, that you have three virtual networks A, B, C are paired like this A to B and B to C. Resources in A cannot communicate with C with resources in C because that traffic can't transit through virtual network B. If you need communication between virtual network A and virtual network C, you must explicitly pair those two virtual networks. Got it? Got it. Gateway transit. You can configure transitive connections on premises if you are using virtual network gateways as transit points. Okay, you can configure transitive connections on premises if you are using virtual network gateways as transit points. Using gateway transit, you can enable on premises connectivity without deploying virtual network gateways. Using gateway transit, you can enable on premises connectivity without deploying virtual network gateways. Using gateway transit, you can enable on premises connectivity without deploying virtual network gateways to all your virtual networks. Without deploying virtual network gateways to all your virtual networks. You can enable on premises connectivity without deploying virtual network gateways to all your. You can, using gateway transit, you can enable on premises connectivity without deploying virtual network gateways to all your virtual networks. This method might reduce cost and complexity. By using gateway peering, you can configure a single virtual network as a hub network. Connect this hub network to your on-premises data center and share its virtual network gateway with peers. To enable gateway transit, configure the allow gateway transit option in the hub virtual network. When you deploy the gateway connection to your on-premises network. Also configure the use remote gateway option in a spoke virtual network. Okay, to enable gateway transit, configure the allow gateway transit option in the hub virtual network when you deployed the gateway connection to your on-premises network. Also configure the use remote gateways option in spoke virtual network. Note, if you want to enable the use remote gateways option in spoke network peering, you can't deploy a virtual network gateway in the spoke virtual network. Hmm. Then you cannot deploy a virtual network in the spoke virtual network. Overlapping address spaces. If address spaces of connected networks within Azure and between Azure and your on-premises data IP address spaces of connected networks within Azure and between Azure and your on-premises system cannot overlap. This is also due to true for peered virtual networks. Keep this rule in mind when you are planning your network design. In any networks, you connect through in in any networks you connect through virtual network peering, VPN, or express route assign different address spaces that don't overlap. Alternative connectivity methods. Alternative connectivity method. Virtual network peering is the least complex way to connect virtual networks. Other methods focus primarily on connectivity between on-premises and Azure networks rather than connection between virtual networks. You can also connect virtual network together through express route circuit. Express route is dedicated private connection between an on-premises data center and Azure backbone network. The virtual network that connect to an express route circuit are part of the same routing domain and can communicate with each other. The virtual network that connect to an express route circuit are part of the same routing domain and can communicate with each other. Express route connections don't go over public internet, so your communications with Azure services are as secure as possible. VPNs use the internet to connect your on-premises data center. VPNs use internet to connect your on-premises data center. VPNs use internet to connect your on-premises data center to Azure backbone through an encrypted tunnel. You can use a site-to-site configuration to connect virtual network together through VPN gateways. VPN gateways have higher latency than virtual network peering setups. They are more complex to manage and they can cost more. When virtual networks are connected through both a gateway and virtual network peering, traffic flows through the peering configuration. Hmm. When to choose virtual network peering? Virtual network peering can be a great way to enable network connectivity between services that are in different virtual networks because it's easy to implement and deploy and it works well across regions and subscriptions. Virtual network peering should be your first choice when you need to integrate virtual networks, Azure virtual networks. Peering might not be your best option if you have existing VPN or express route connections or services behind Azure basic load balancer that would be accessed from a peered virtual network. In these cases, you should research alternatives. Peering might not be your best option if you have existing VPN or express route connections or services behind Azure basic load balancer that would be accessed from a peered virtual network. In these cases, you should research. Hmm. Might not be. Peering might not be best option if you have existing VPN or express route connections or services behind Azure basic load balancers that would be accessed from a peered virtual network. In these cases, you should research alternatives. Next exercise, prepare virtual networks from peering by using CLI commands. Okay, let's do that. Let's do that. Let's do the let's do the. Okay, prepare virtual networks peering by using CLI commands. Okay, let's activate the sandbox. Let's say your company is now ready to implement virtual network peering. You want to connect systems that are deployed in different virtual networks. To test out this plan, you will start by creating virtual networks to support the services your company is already running in Azure. You need three virtual networks. The sales virtual network is deployed in North Europe. Sales system use this virtual network to process the data that's added after a customer is engaged. The sales team wants access to marketing data. Marketing virtual network is deployed on North Europe. Marketing system use this virtual network. Members of the marketing team regularly chat with the sales team to share their data with the sales team. Okay, marketing systems use the virtual network. Members of marketing team regularly chat with the sales team to share their data with the sales team. They must download it because the sales and marketing systems aren't connected. The research virtual network is deployed in West Europe. Research system chooses virtual network. Members of the research team have a logical relationship with the marketing, but they don't want the sales team to have direct access to their data. But they don't want sales team to have direct. Okay, yeah. Members of research team have logical working relationship with marketing, but they don't want sales team to have direct access to their data. So North Europe में sales VNet, marketing VNet 10.1, 10.2, then research VNet in West Europe 10.3. Then we have subnets 10.1.1.0, subnet 10.2.1.0, subnet 10.3.1. You'll create following resources: sales VNet, marketing VNet, research VNet. North Europe 10.1, 10.2, 10.3. Okay, subnet apps, subnet address space 10.1.1.0 slash 24, 2.1.0, 3.1.0 slash. Create the virtual networks. Let's create VNet create sales VNet. Location North Europe. Ta-da, 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 ta-da. Okay. Okay, sales VNet is there, marketing VNet. Let's create marketing VNet and run the commands to create the virtual network and subnet for research systems. Sure, why not? Let's create the research VNet. Confirm the virtual network configuration. Okay, is it network VNet? Create resource group, name research VNet, address. In cloud shall run the following commands to view the network. Is it network VNet list, output table, output YAML. Oh, YAML has tons of information, bro. Anyways, create virtual machines in each virtual network. Now you'll deploy some Ubuntu VMs in each virtual network. These VMs simulate the services in each virtual network. In the final unit of this module, you will use these VMs to test connectivity between virtual networks. Okay. So in Cloud Shell, run the following command, replacing password with a password that meets requirement of Linux VM to create a Ubuntu VM in the apps subnet of sales VNet. Note, use this password for later use. Okay. All right, let's do that. Okay, is it VM create Azure user password? The no wait parameter in this command lets you continue working in the Cloud Shell while the VM is building. Okay. Run the following command, replacing password with the password that meets the requirement of Linux VM to create Ubuntu VM marketing VNet. Okay, let's do that. VNet or Q. Let's create the marketing. Run the following command for research VNet. Cool. Apps data. Okay. So research VNet भी हो गया, marketing VNet, research VNet. To confirm the VMs might take several minutes to reach running state. To confirm the VMs that are running, to confirm that the VMs are running, run the following command. This uses the Linux watch command, which is configured to refresh every 5 seconds. Okay. So watch command is it VM list resource group show details, and then yeah, succeeded. Cool. A provisioning state of succeeded and a power state of VM running indicates that successfully deployment for the VM. When your VMs are running, you are ready to move on. Press Ctrl C to stop. Command and continue. Sure. Configure virtual network peering connection using CLI commands. Of course, why not? Yeah, to create, you have created virtual networks, run virtual machines within them. But the virtual networks have no connectivity, and none of these systems can communicate with each other. To enable communication, you need to create peering connections for virtual networks. To satisfy your company's requirement, configure a hub and spoke topology and permit virtual network access when you create the peering connections. Create virtual network peering connection. Follow these steps to create connections between virtual networks and configure the behavior of each connection. In Cloud Shell, run the following command to create a peering connection between sales and marketing virtual network. This command also permits virtual network access across this peering. Create peering connection. This also permits virtual network access. Sure, why not? Peering creates sales to marketing, remote VNet marketing, sales, allow VNet access. Run the following command to create reciprocal connection from marketing to sales. Sure, okay. This step completes the connection between these virtual networks. Now that you have connections between sales and marketing, create connection between marketing and research. Okay, why not? We'll do that. Ta-da, 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 ta-da. Okay, okay, I can do that. I can do that. Yay. So we have created between marketing to VNet. Now that you have connection with the sales and create connection between marketing and research. Marketing VNet to research VNet. Sure, why not? And then create a recipe. Run the following command to create reciprocal connection between research to marketing. Of course, why not? Let's do that. Na 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 na. Okay, so we have created from marketing to research. Now configure reciprocal from research to marketing. Allow VNet access. Check the virtual network peering connections. Now that you have created the peering connections between virtual networks, make sure the connections work. In cloud shall run the following command to check the connection between sales and marketing. Okay, let's see peering list, output table, connected. You have created only one connection from sales VNet, so you see only one result in the peering state column. Okay.